Hi, hello everyone. Welcome to this video, and here we are going to cover rendering using WebGPU render pipeline. So you kind of have to get idea of what the render pipeline is in computer graphics. And if you're already familiar with this, you can probably skip this part, and I'm going to leave mark in the description of the video. You can just skip it over. But for those who don't know what the render pipeline is, we can just go through these slides. It's composed of multiple stages. That's why it's called pipeline, right? And then it's the responsibility of pipeline when we talk about graphics is just to draw something to the screen. So it can be, well, it doesn't have to be to the screen. We can also draw to the off-screen texture, and that's what it says here. So it kind of looks like this. And we kind of go from the input stage, and then we go over this. So this is very simplified view, but it's like that. And input, it just means the data that we're going to send to our GPU. Usually it's going to be probably points, maybe texture coordinates, normal data. We're going to cover all of that. But just so that you know, it's data that we send from C# to the GPU. Then it comes next stage of the pipeline, which is called a vertex shader. And vertex shader is kind of program that we execute on the GPU. And it kind of says where the stuff will be on screen. So it's primarily going to be responsible for transforming stuff around and just to position it somewhere on the screen. That's the programmable part of pipeline, and we're going to get to it. We're going to write our vertex shader this time. Then we have primitive assembly. That part of pipeline which can just set some properties, but what it means is because with this graphics APIs, you kind of have this idea of primitives, and that's the smallest object that you can draw. And usually it's triangle, but it can also be a line, and it can be a point. So usually if you see a model, right, in a game, it's made of a bunch of triangles, right? And that's what primitive assembly does. It does triangulate that stuff. Then we have rasterization part. So it just means that it's going to create fragments or pixels for the shape. So that's the part of the rasterization. We don't have much control over it. But the next part of the pipeline we do have control over, and that's the fragment shader. So if we draw some shape, let's say here it's triangle, but it can be cube, it can be a model as well. And the fragment shader kind of answers what the color of individual pixel, right, within that shape is going to be. So it's also programmable part of the pipeline. We're not going to do much with it this time. We're just going to output color red. But next time already we're going to do a bit more. Then we have color and blending part of the pipeline. So you already have something drawn, right, to your texture. And you need to draw a new shape there. So what do you do with color and blending? What if your object is transparent? So this part does that, right, color and blending. So we're going to have the whole video on it because it's very complex topic. Actually, it's not that simple. So for now, just know that this color and blending part is actually responsible for answering question what to do with our opacity, right? What if we have some transparency? What do we do with colors if we need to draw something over some other shape? And then we just output the screen. That's very easy. Not much there. So I just prepared some points, but this we already discussed it. Input, we need to describe our input data. Then we have vertex shader stage, that's programmable part. So it's mainly responsible for transforming vertices and mapping them to view space. Right, primitive assembly, we can kind of say draw points, draw lines, draw triangles. Rasterization, we create pixels from shape. Then we do fragment shader, once again programmable part of the pipeline. We have direct control over it. We kind of color that pixels or fragments. Yeah, color and blending, decide what to do with blending, then output screen, write to screen. So how do we create that pipeline? Well, the WebGPU has this object called render pipeline, and go figure. And it just represents this idea of graphics pipeline. Actually, not idea, it's graphics pipeline. It's what your GPU does, right? But it's an object with which we control that pipeline and its stages. Mainly vertex fragment stage. Then we can define input and primitives, define where to draw and how to blend stuff. And then this vertex and fragment shader, I just wanted to give a bit more explanation on that. Those are the actual programs, right? Your code that will run on the GPU. They're very specific, right? They do one stuff and they do it very well. But the vertex shader kind of answers where the vertex will be, where our objects will be on the screen. And the fragment shader answers what the color of them will be. And for the WebGPU, we can write them in a couple of formats. That's WGSL, SPRV, GLSL. WGSL is specific for the WebGPU, but we can also use other formats, right? Because WebGPU just runs on top of other APIs. So we can define SPRV, that's binary format, and usually it's compiled format, right? You can pre-compile shaders. That's where this that's what this format was created for. We can also write GLSL, no, sorry, GLSL shaders. I'm getting confused here, and which are commonly used for OpenGL. And we're just going to cover WGSL, right? So actually, I'm pronouncing this wrong. It's not WGSL, it's WebGPU shading language probably. So my bad. I'm a bit ahead of myself. But yeah, that's it. Let's just jump to our code. So when it comes to our code, we left off with kind of this screen. But I already know, because some of the stuff, right, we're going to need some of the stuff here public, because we're going to need to use it for creating this pipeline. So the stuff that I need public, I'm just going to copy and put it somewhere over here before initialize, and then you can refactor this and rename. And I'm just going to use here capital case for all of those, and I'm just going to make it public. And I'm going to say get, and then private set. So I'm just making getters and setters for it. And then I know that I'm going to need device for sure. What's happening? My bad. Device. And it was like this, so I just need to rename it. Pascal case, and then it's going to be getter and private setter. And one more that we're going to need, and is this current pass encoder. If you remember last time when we created it, it was mainly used well, it's right. I mentioned last time we kind of have to create these commands, and the commands go into queue. And part of those commands is current pass encoder, which is responsible for rendering. We covered it, I believe, last time, if I'm not mistaken. So we're just going to create it, and then I'm just also going to refactor, rename it. We're probably going to need a queue, but not this time, so I'm just going to leave it here. These three I know that we're going to need, and I just like to have some kind of hierarchy here, because this is the most important object, right? It's our API. But that's something that we're going to cover a bit later. Let's actually create our shader, and that's probably a good point to go from. So I'm just going to put shaders here, and I'm just going to call this one, we're going to create a new file. I'm going to call it unlit, and then WGSL, because that's our format. All right. So here we're going to need a couple of stuff. We're going to need to create that. Let's start with fragment shader. And how do we set up fragment shader? We can just use keyword fragment, and then goes fn for function. And then I'm just going to call this main fs for main fragment shader. And what we're going to output from that fragment shader is just a caller at location 0. So I'm going to cover location somewhere in the future, but for now just know that this location means that we're outputting the first color attachments. We can have multiple color attachments, so that means we can render to multiple textures. But we're just going to render the first one, which is going to be texture that we're going to send to our screen to present. And here I'm just going to return basically red color, and it needs to be in format vec for f 10000010. Why this vec4? Because we have a red component, green, blue for color, and then alpha as well, right? So for our vertex shader, we can create that one now. We're going to use this built-in, and I'm going to explain it a bit later, but just type it out for now. And then this keyword inside must be vertex index, and I'm just going to call it id, and it's of type unsigned integer, so u32. And here we have to output something as well, but actually what I'm going to output is, we can just output position, I think. So we have to use built-in once more, built-in, and we can say here position as our keyword, and that's going to be our position on the screen. So what we kind of want to do is this, maybe. So what do we want to draw? I just want to draw our triangle that's going to go to screen, and in WebGPU space to which you kind of can draw is going from -1 to 1 in x and -1 to 1 in y direction. Also for z we have 0 to 1, but that's not relevant now. And so this triangle is going to have coordinates here, and this is going to be first one, -0.5, and then -0.5, right? And here it's going to be 0.5 minus 0.5, and here it's going to be 0 and then 0.5, just so that we can draw some triangle and have some shape on screen. So with that said, so kinda this vertex index, maybe I can bring that back in. No, maybe, please. Okay, it's deleted. But with that vertex index, right, I mentioned that we have one vertex here, and I'm just going to say 0, here 1, and here 2. And when this vertex index gets passed in, so somewhere with our pipeline, once we create it, we can say how many times do we want to run that vertex shader. Well, we want to run it 3 times, once for each vertex. So it's going to be once for this, and once for this. So we can actually leverage that, and we're going to do this now. So we're going to say if this vertex index is 0, so if the first one, what we're going to do is just return, what do we need to return? Vector 4f. So I mentioned -0.5, -0.5 for bottom left one. Then for z we don't care about, and this w, or last component of the vector, it's going to be 1.0. And I'm going to explain that one later. It's really important in one of the next videos, but here we're just going to return another vector, and here the z is, x is going to be 0.5, and then else we can just return that top one. I don't even have to say else. I can just say return for f 0.0, 0.5, and then 0, 1.0. I think we're good. It's complaining about something here. I don't quite know what, but we'll see. If it compiles, it compiles. If not, we're going to figure it out. But let's start with our pipeline actually. So for our pipeline, let's do, I'm going to need new folder, and I'm just going to call it pipelines. And for this unlit, you just kind of have to copy it to output directory so that we can reference it by shaders. Otherwise you have to pull full path in, and you cannot use relative one. So we just want to copy if newer, but on Linux something was wrong with this, so I'm just going to use copy always. All right, let's start with our pipeline, and I'm going to call it unlit render pipeline. So here what I need now is this reference to engine, because we're going to need that GPU device and pass encoder. So I'm just going to say engine here. We're just going to have public unlit constructor, right? And I'm just going to say engine, right? And then we can assign that engine. And I'm going to do everything through initialize method. So whenever we create an instance of unlit render pipeline, we're just going to call initialize as well. Okay. So first part would be actually to load that shader in. And for that, we can use shader module. So that's going to be reference to our shader. And we can just create it. And here we finally need that engine, this WGPU, right? And here we're going to say shader module device create shader module. So it needs device engine device. That's why I made it public. And then it needs shader module descriptor. So this is a bit complex and it's actually not that easy. It's a bit tricky. It's a bit trickier than in JavaScript when we need to create a shader. So what we're going to create is shader module. And if you take a look at here, we have shader module descriptor, but we also have this spur v descriptor and then WebGPU shader language descriptor, I guess. But we're going to use this one. It's just this is going to be a bit tricky, not right this, but you're going to see what I mean. And I'm just going to call it actually WGSL descriptor. And we need to pass code in to it. And it's as usual, it's going to be a byte pointer. And then we're going to say Marshall string to that pointer, right? And it's going to be some shader code, which we haven't even loaded in. I totally forgot about it. So we're going to have string shader code. And then we can say file read all text. And then we put it in shaders and then unlit. Shaders, unlit, WGS. So. All right. I think this should be good. It's complaining about something. It's because it's not unsafe. Right. We need to make it unsafe so that we can work with pointers. And here we have this chain, and I just want to set on chain as type W shader module. Yeah, exactly. Sorry, I'm talking to myself. So we kind of need to set up this shader module descriptor type because this is kind of working with C API because headers for desktops are actually in C. That's what they provide, so it's a bit unusual, but in C I guess we have to do this kind of things because C doesn't really have objects, it just has structs, so it's kind of weird. I'm not used to C, but like you have to figure this stuff out a bit. But we just have to paste it like this, and then we can create the descriptor, new shader module descriptor, and we're going to say descriptor that next in chain. This is one of those quirky stuff. So it kind of takes chain struct, and what's our chain struct? Well, it's a pointer to the descriptor that we have created, right? We just have to cast it. So this is basically saying we create shader module descriptor, and if we want to have class, let's say class, like we're in C#, we're not taking C now. If we want to have a class that actually inherits from it, because C doesn't have that concept, we kind of create another object that's very similar, right? You could imagine this as inheriting from this, and then we just need to pass it here so that it knows what's next in chain, I guess. Right, that's pattern. It's weird, but I haven't decided on the API, so there it is. And I'm actually just going to move this to private shader module, and I'm going to call it create shader module. And here I'm just going to say console, right line, shader module created. So just that we know that it's created, and then we can return it. And then I'm just going to call it here once more. Create shading module, right? So we can probably create that pipeline, and let's do just that. If I go to our program, so we're going to need some kind of callback here so that we know when the engine is ready. Because right now, if we take a look at the engine, when we initialize it, we start this render loop. And this is not, until we exit, nothing is going to happen. So we can probably have kind of event here that's going to be a callback. So let's do that. And neat thing with C#, it kind of has this event loop built in. So we can just say public event and then action. And then we can call this on invoke. And here we can actually call that on invoke. And this is probably a safer way to use it, right? We can invoke it and we can do this question mark. So if it's nullable, it's not going to invoke it because it will be null if you don't paste anything to it. And how do we paste stuff to it? Well, we just go here. We're going to say, let's first create that unlit pipeline. Unlit train the pipeline, unlit train the pipeline, it's new. Then we paste engine in, and then engine dot initialize, right? Sorry, not initialize, on, not on invoke. Oh my god, on initialize. So I kind of wanted to have this. So let's just fix that real quickly. So here it's on initialize and here as well. And then in program on initialize, we can say plus equals, paste some function in, and we're going to call on it in the pipeline initialize. So let's see if this will actually compile the shader. And it says right here, shader module created, but actually it isn't created. We have parsing error here. So I guess we haven't specified type here, which is vector4f, and that's the problem. Ah, yeah, that's it. I just forgot to specify type for this building. It says shader module created, no errors. Cool. We have created our shader. So now we can start with that pipeline. So where do we start from? So input part of pipeline I'm going to skip for now. We're not going to deal with that. That's going to be topic of next video. But here we're just going to create vertex state. And so let's just see details to fill in. We basically have entry point, then we have module, which we created now. And this we're going to cover some of this stuff next time. So module is our shader module, and then vertex state.entry point is once again byte. So we just need to paste that name of the vertex function, which was this main vertex shader. Most, and I can probably move this bit down. So it's going to be Marshall string to this, and then which string? Well, our function. So that's for the vertex state. Next thing, we're going to need to create fragment state. While we're at it, let's just configure shader first. So fragment state is that part of the pipeline that's responsible for coloring fragments. And here we just said, okay, just output red. So let's do that. It's also going to be similar to this, so I'm just going to copy paste it, and we have to say fragment state, and then I just used fragment shader for the name. But fragment state, what do we need to fill in? We're going to need to fill in targets. Now it gets a bit tricky because these targets, call a target state. I'm going to explain it. So let's And I'm going to use stack alloc here because this is actually an array, because targets, let's just say null here, and let me just write this in, and then I'm going to explain it. If you see fragment here, it has targets count, right? And because the C, right, the headers are from the C language, you kind of have to pass array like this. They're just pointers, and then you kind of have to say, okay, the count of elements, right? And the count of elements is going to be 1 because we just have one color target state, right? But just so that you're not confused, here when it says pointer, it actually means kind of an array. It can be an array. It can be single object, but it also can be array because we can have multiple color target states, multiple color attachments, right? Because we can draw to off-screen textures as well. But let's just configure this one. And here, all right, let's see. What do I need to fill in? Just give me a second. So we need to color targets state. We need to set up a right mask. So we can mask channels, but we just want to write all of the channels. So red, green, blue, alpha. Format. Now this is important and I forgot about it, but the format needs to be the same format that we actually specified for our surface somewhere over here, I guess. This one, right? It kind of needs to be same format. So what I'm going to do is just cut this out. I'm going to say preferred texture format, and then we can create a variable for it so that we don't have to think about it. We're just going to use our engine and then preferred texture format. So I'm just going to say here texture format and then preferred texture format. And what do we return? Well, we return this format, and then here I can just say engine preferred texture format. All right, so now blend, that's an object and we kind of need to create it. So I'm just going to create here blend state, and it's once again it's just going to be a pointer because we can probably have multiple blend states. No, can we? Let me see. No, it's a single object, right? Because it's per color attachment blend state. But I still need to create it like this because otherwise you might run into troubles. So it's probably best to create it like this and just stack allocate it instead of heap allocate it and then figure out what to do with pointers. So let's just do it like this. And so here we can configure color. And I'm not going to go into details here. I'm just going to fill it in, because we're going to have a whole lecture on this. So it kind of answers what to do once we have to merge our newly drawn object to what was already drawn previously to texture. So I'm not going to waste too much time here. I'm just going to fill in those details. So destination factor is 1 minus source alpha. Right, and then operation, we just want to add. And then very similar, I'm just going to copy it. It has another property which is called alpha, and it's going to be exactly the same, so we can paste that blend state in. Cool, I think that's it what we need for that fragment state. Cool. So let's finally create that random pipeline descriptor. So I'm just going to call it descriptor here. So beside this, so let's start pasting that in now. So we configured our vertex stage, right, of the pipeline. We configured fragment stage of the pipeline. Fragment state, it needs to be a pointer, probably. Yeah, it takes pointer in. So you could also create blend state probably, like we did here. It might be easier actually for you. I don't know why I did it that way, but I did it. So let's just leave it. I might fix it for the next video. But let's see further. So we're going to need this multi-sample, and I'm not going to cover multi-sampling just yet, but let's just fill in the details here for the multi-sample. it kind of, you can kind of think of pixel, like it's not just simple pixel or fragment that you have. It can be actually multi-sample, and that's usually has to do everything with anti-aliasing because you can fix it. But it's a big topic, and I'm just not going to waste too much time on it, at least for now. In the future, probably. So we can say here mask is this, count 1, and then coverage enabled. This is false. It's probably all right. Then one part of the pipeline that's very interesting to us is this primitive, and I mentioned we have this primitive assembly state where we kind of want to figure out what do we want to draw. Do we draw triangles, lines, points? So that's what primitive state does, and we're going to have property call mode, and I'm just going to say call mode back. So when you draw a cube or whatever, right, it has front and back face, and you can call back face in, so it's just going to save some rendering time because it doesn't have to draw like the side of the object that's not visible. Then we're going to say front face is counterclockwise. So let's actually explain this real quick. So let's say that we have triangle. So we can either draw these indices counterclockwise or clockwise, right? So I'm just going to say counterclockwise, and that's going to be our order from now on. It's very common. So let's go a bit further. And finally, so this is probably most important property for you. What do we want to draw? So you can see that we can draw line, list, line strip, point list, triangle list, or triangle strip. So triangle list, triangle strip, no difference. It's just how do you arrange the vertices. Same here, but we're going to do a triangle list for now. And then I think that's it. Let's just create here. We're going to say private render pipeline. And then we can say render pipeline is equal to, engine. Create render device, create render pipeline, engine device, and then that pipeline descriptor. And I'm just going to do console right line pipeline created. Okay, moment of truth. Let's see if our pipeline is created and if everything is all right. And you can see it here. It says pipeline created, so nothing went wrong. If I try to break something, let's say count here, I'm not sure that that's going to break it. You're going to get warning if something is wrong. And it says right here, format cannot be multi-sampled, right? So we know that it's good, it's created. So we just need to draw it. Okay, let's get that pipeline working. So we kind of need to render something to screen. So we're going to have render function. And here the first thing that I'm going to need to do is just to set up that pipeline so that it's used. So we can say our engine, right? WebGPU. So we need to set render pipeline. So pipeline, let's see which one would be good. It's not device. Here, compute pass encoder set pipeline. So we do it through the compute pass, not the compute. Sorry, my bad, the render pass. I'm ahead of myself doing the rendering, not the compute shaders. So we just need that current pass encoder, right? Which I mentioned last time, right? Command encoder encodes render command. So that's what we're going to do. We're going to encode render commands, and we just need to pass our pipeline that we have created, render pipeline, and then we can just draw with it. So we're just going to say engine, this, and then draw, render pass encoder, draw, right? So we can encode draw command. So we're just going to paste that render pass encoder. So once again, engine, connect render pass encoder. So how many of vertices are we going to draw. I mentioned that we can kind of give command how many times do we want to execute this function. So we want to execute 3 times, once for this one, once for this one, and then once for this one as well. So 3 times. Then we have instance count, which is next parameter. I'm just going to place 1 because we're going to do instancing a bit later. And the first vertex is 0. We start with the first vertex 0, and then the first instance is 0 as well. So similar to what we did with this on initialize, we're just going to have on render somewhere over here, and this on render is taken, so I'm just going to say it window on render. Going to rename this and call it here, and then we're going to have on render, right? I haven't created it yet, so let's just create that event as well. Similar to this initialize, we're just going to have public event action on render. In our program, what do we want? We want engine on render plus equals initialize, not the initialize, render. And if I try to render now, let's see. Yeah, here we go. We have triangle. So we did hello world of computer graphics actually. So I'm just going to recap it real quick. If you already know all of this, you can kind of skip recap. So let's try to explain it once more. I'm not going to go to the slides, but we actually had this idea of render pipeline, right? And we created pipeline right here, right? We have these stages, vertex, input we're going to cover next time, because right now all of our data is actually in shader. If I go here, data is in shader, but that's not going to be the case at all, right? This is just, you can do this, but yeah, that's not going to happen already in next video, so we're going to move that out. But here the next stage was called vertex stage, and that stage runs, all right, this function, and it kind of says, okay, here is where the points will be on the screen, right? So it kind of assigns these vertices and where they are on the screen. So that's the point of the vertex stage. Then next stage was rasterization. We don't have control over that state, but next important state was, right, primitive. So what do we want to assemble? And we said, okay, we just want to assemble triangle from it. If I change this to, let's say, line list or whatever, right? So it's going to be wireframe right here, or better yet, line strip. So it's not whole, right? Because I don't have last vertex, right? I just need to connect this. So I would need to pass in 4 vertices. For now, I'm not going to do it. I just wanted to showcase it. You can use points. It's not like you're going to see them. So I'm not going to do that. So that was our primitive stage. And after that, we had rasterization, no control there. It's just the WebGPU is going to do it for us. But the next stage, which was important, was our fragment stage, right? Where are you, fragment stage? Here, right? And it runs the fragment here. So we just kind of said, okay, output for each fragment, output red color. So next time we're going to play with it so that it's not red. But it also, we had set up color attachments, and we said location 0, but you can have multiple locations if you want to render to multiple textures, and then you can output here another color, right? You can have one color for one texture and then the other color for other texture. Common use cases, post processing, you kind of need effects that are a bit different, right? Okay, so unlit render pipeline, we did that. We needed to configure this blend state, and we're going to cover blend state in future. For now, it's just kind of answers. I'm referencing wrong code. Where is the blend state actually? Here. Blend state kind of answers what to do with our shape once we kind of have to, let's say, paste it to our target texture. So the blend state is going to be important once we kind of try to figure out what to do with transparency, right? And stuff like that. It also kind of answers what to do if we have our new color, which is our new shape that we kind of have to paste to this old basically texture that we already have. That kind of what to do if we need to apply new stuff to the texture that was already drawn to. So like I mentioned, for the future. And then last step is nothing. We just had to draw, right, everything. And then in engine, we just kind of submitted everything, right? So that's why we had this render. So we kind of encode to our command encoder, and then we just end everything and just like send it to GPU and present the surface. And that's it. That's how it works. Okay, this was hopefully not too long video, and hopefully everything is clear. I mean, if you're new to this, probably nothing makes sense, but it's practice, right? You get better at this and then you're going to understand it. So just hang on. Probably everything is going to click in time. And yeah, if you like the video, maybe like, leave a comment, subscribe. Next time, we're going to do that input part of the pipeline, which is very first part, but it's kind of doesn't make sense to do it immediately. So that means this data that we have here, we're going to move it to C# code, and then we're going to paste it in to our pipeline, like here somewhere, right? Probably to vertex state. Okay, that's it, folks. Yeah, all the best.